Okay, next slide. Okay, we also like the node voltage. We also have mesh analysis with the dependent sources lah. Okay, so if you remember dependent sources, you need to come up with the constraint equations lah. Okay, so for this one you need to come up this I naught with the constraints equation. Obviously here you can get this I naught, right? This I naught, just follow the current directions. Okay, so this is going to be your I1, this is going to be your I2, and this one going to be your I naught. You can find your I naught here lah. So here obviously I1 equal to I2 plus with I naught, and your I naught is going to be equal to I1 minus with I2. So this is the constraint equation for your I naught here. Okay, so just note that your I naught is actually equal to I1 minus with I2. Okay, so you need to substitute this I naught inside these equations lah. Okay, so let's see, the question asks you to find I2, I3, I1, I2, I3, and I naught as well. Okay, so from here, what you can do, you need to find first with this I1, I2, and I3. Okay, let's try with mesh I1 lah, mesh 1. So what you have is, in this loop, what you have, let's start from here lah, negative 24 plus with, when you add this two when you add these two resistor, you will get 22 I1. Okay, and then you need to minus it with 10 I2 minus with 12 I3 equal to 0. Okay, so you might want to rearrange this, okay, where you can have 22 I1 minus with 10 I2 minus with 12 I3, then bring this 24 this side, so you will have 24. Okay, if you see this equation, you can simplify this equation. You might divide this equation by 2, I guess. Okay, I think you can divide this by 2 so that you can get these equations lah. All right, so just divide all of this with 2 so that you will have your first equation is this one lah. Same goes with mesh 2. Okay, so same goes with mesh 2 here. Okay, so let's add up all the resistor that you have inside this loop. So you notice that here you will have how much resistor you have here with 14 and 24. You will get 48, right? 48 I2. Okay, 48 I2. Okay, 48 or 38. I think it's 38 I2. 38 I2 minus with 10 I1 minus with 4 I3 equal to 0. Okay, you can rearrange this equation where you can put I1 first and then I2 and then I3 lah, so that here you will get 10 I1 minus with 38 I2 minus with 4 I3 equal to 0. So you can simplify this as well, which is you can divide it by 2 as well, I guess, so that you will have this equation. All right, divide by 2 and then you need to simplify, then you will get this equation lah. Same goes to mesh 3. Okay, so mesh 3 here, so obviously it will goes you will have 16 I3 minus with 12 I1 minus with 10 not 10 4 I2 and then plus with 4 I naught equal to 0. Okay, 16 I3 minus with 12 I1 minus with 4 I2 and then plus with I naught. So the important part is here lah, the constraint equation. I already wrote to you the I naught is equal to I1 minus with I2. So you just need to substitute this value inside here lah for this I naught. And then when you substitute, you will have this equation lah when you simplify. Okay, so now means that you already have three equation where you have equation 1, equation 2 and equation 3. So now you can solve your equation using the Cramer rules. Okay, so this is actually same goes with the like a node voltage analysis lah. Okay, so I think that already show you how to solve it using the Cramer rules lah. Okay, so this is actually all these three equations seems like a linear equation lah. So you can solve it using Cramer rules, and then when you solve that equation, you will get this lah. I1 equal to 2.5, and then I2 0.75. I3 1.5, and then we have I naught, which is I1 minus with I2, which is equal to 1.5 ampere. Okay. Okay, so we have another example lah here. I think that I'm not going to show you in details, but I'm going to show you how to get this constraint lah. So obviously this constraint here coming from I naught here lah. So I naught here is this one. So I naught here obviously equal to I3 lah. Okay, so here it's gonna be 10 I3. Okay, because this I naught is actually this one, so it's regarding these loops lah, which is mesh I3. So I naught is equal to I3. So the first thing that you need to do is find the equation for I1, for I1, I2 and I3. Okay. Okay, so let me write it again. So I naught is equal to I3. So the first thing you need to do is find this equation for I1, I2, and then I3. Okay, for this I1, this equation gonna be negative 16. Okay, plus with this is gonna be 6I1. Minus with 2I2 minus with this one 4I3 equal to 0. Okay, and how about this mesh 2? Okay, mesh 2 obviously it goes like this, gonna be 10I3 where I already replaced I naught with I3. Okay, 10I3 plus with 10I2 minus with 2I1 minus with 8I3 equal to 0. This is for your second equation, and this is your first equation lah. And then for this mesh 3, what you got is 12 with 6, which is you got 18I3 minus with 4I1 minus with 8I2 equal to 0. So this is your third equation. So you have these three equations, 1, 2, and 3. And so now you can solve it using, again, the Cramer rules lah. Okay. Okay. So that's your answer. And then this is the solutions lah. So if you stuck, you can just refer to this solution in how to solve for this one. Okay, so that's the solutions lah. Okay. Okay, so this is the answer lah for I1, I2, and I3 as well as I naught. I naught is actually equal to I3. So it's have the same answer with I3 and I naught lah. Okay. And then we have another example. This example is actually with this dependent sources as well lah. So if you look at this dependent, which is 200 and I. So just look at this I. I is actually depends on this I lah, where your I here, the connection of I here is actually I1 and I2 here. So obviously your I here is actually equal to I1 minus with I2. Okay, so you can just write it straight away. Okay, if you want 200 times with I1 minus with I2 here, which is here you can have 200 I1 minus with 200 I2. So I think this one is easier, so that when you do the equation for this mesh, so you can just directly put the value for this dependent sources with this value lah. Okay. So let's look at this. First mesh here, right? So I'm just going to show you how to come up with the equation, and then I think that the rest you will have to do yourself lah. When I want you to solve the equation, because I already give you the answer here. So now then after that you can compare lah your answer whether it's correct or not. Okay. But for this one, let's go with this mesh one first. Okay. So this mesh I1 here is actually equal to -5 plus with 1100 lah, ohm times with I1 here minus with 600 I2 equal to 0. Okay, this is your first equation lah. And then for your mesh I2, so just bear in mind this one, we already did it, 200 I1 minus with 200 I2. Okay, this is the constraint equation for this dependent sources lah. Okay, so what you have here, so inside this mesh I2, you can just add straight away the resistance, where you have 900 with 4. So you will have 1300 I2, 1300 I2 plus with this one lah, plus with 200 I1 minus with 200 I2, which is this one, and then minus with 600 I1 equal to 0. Okay, so you can just simplify this one, okay, by just solving for I1 first, where you have 800 I1, okay, not 800, 200 plus 200 minus with 600, you will have negative 400 I1. And then you will have this one as plus with 1100 I2 equal to 0. This is for equation 2. All right, so you already have equation 1 and equation 2. So you can solve for that. So you can get the answer lah. Okay. All right. Okay, for that one, when you calculate that, you can solve these two equations, right? Using, I think the easiest way is elimination method lah. Okay, so you can solve that using the elimination method. Then you can get I1 is equal to 5.670 milliampere, and then I2 is equal to 2.062 milliampere. Okay, so now you have your I1 and I2, and you can find your I here as well, right? Where you know that your I is actually equal to I1 minus with I2, so that your I is actually equal to this value minus with this value. So when you calculate, you get 3.608 milliampere for this I. Okay, so now the question also asks you to find the value for V1, V2, and the value for V1, V2, and the V3. Where's the V3? Oh, this V3, sorry. Okay, V1, V2, and V3 here lah. Okay. All right. So, Okay, so what you can do is that, so V1 here, V1 is actually equal to, V1 is actually equal to here lah, 600 times with I. Okay, 600 times with I. So you can get your answer is actually the answer is I guess 2.1648 volts lah. And obviously for this V2, okay, V2 here, V2 here, you can find your V2 by this. This is, you know that this one is actually I2, right? The current that flowing through here is actually equal to I2. So you can have like I2, just follow the directions here. So it means that V1 minus V2 over 300 is equal to I2. So you already have the value for your I2. So you can find the value for your V2. Just bring it here. So 300 I2 equal to V1 minus V2. So obviously, you just have to substitute the value that you already have, lah, I2 and V1. So then you can find that your V2 is actually equal to 1.5462 volts lah. Alright, same goes with this V3. V3 is actually this source lah, 200 times with I. So for V3, it's actually equal to 200I. So 200 times with this value for I, okay, where 200 times with 3.608. So then you can find your V3 is equal to 0.7216 volt lah. Okay, so means that you have all the answer lah. I1, this one I1, I2, V1 here, and V2 here, and then V3. Okay. So let's move to another slide. All right. Okay. For mesh analysis, seems like a node, we have a super node, and for mesh, we also have the super mesh. So the super mesh, what does that mean by the super mesh? Super mesh is that when you have a current source in common, means that you have the loop that sharing the same current source. Okay, let's see, like, okay, let's see here, right? So for example, let's see you have this node I1, the mesh I1, and this one is I2, and then you have the current source here. So means that this mesh I1 and I2 is sharing the same current source. So this one we call it as a super mesh. Okay, so this kind of result of for a super mesh lah. Okay, so usually super mesh is created by excluding the current source and any element connected in series with it lah. Okay, so same goes like with the super mesh. Super mesh, we can calculate the super mesh equation by using both KVL and KCL lah. Okay, so I think that let's straight see the example lah. Okay, for example, if you have this current source, right? You have this current source where this current source is sharing by these two mesh I1 and I2. So for this one, you're gonna have this as your super mesh lah. Okay, so this is the super mesh. So how to get the equation inside the super mesh? Okay, so when you have the super mesh, so this one also excluded lah. Okay, all right. So in order to have the equation for this super mesh, you just follow the loop here lah. You know that your current directions for your loop is this way lah. So means that it will start with negative 20. Okay, negative 20. Then plus with 6I1 plus with 10I2 plus with 4I2 equal to 0. So means that you can just put these two mesh in one equations. Okay, so it's like these two mesh are combining together lah. So you will have this equation. That's how you can get the equation using the super mesh lah. Okay, so mean that the super mesh make your analysis is more easier lah. Okay. Okay, so for super mesh, you will have, so like that one. Okay, we have the super mesh, and also we need to come out the equation at node 0. So what is node 0? Node 0 is actually here lah. Okay, node 0 where the super mesh it's happen lah. Where you have the super mesh, that's the place that we call it as a node 0. Okay, so for node 0 here, obviously, okay, node 0, if you see the how it works, okay, so let's see the directions of the current. You can see this one is this way, and then this is I1, and this is I2, which is entering the node. So let's see here, we call it, this one is actually 6 ampere lah for this one, 6 ampere, and then this one's gonna be I1, and this one gonna be I2. So this equation gonna be I2 is equal to I1 plus I6 at node 0. Okay, so means that you have two equations, so you can solve using maybe elimination method in order to solve for this equation, so that you can have the result for I1 and I2 lah. Okay, so so what you get from this super mesh is it's the same like a mesh, the normal mesh analysis, where you know that when you have two meshes, so means that you need to have two equation, where like for super mesh, this equation coming from one is from this super mesh, and another one is from node 0. So the equation will come from the super mesh. Okay, super mesh, where this super mesh is actually combination of this mesh 1 and mesh I1 and I2 lah. So this super mesh coming from mesh I1 and mesh I2, and another one is and the second one is the equation coming from this node 0 lah. Node 0 where you have this super mesh is happening lah. Okay, so this is only two equation that you have lah. Okay, so means that it will simplify your analysis lah. Okay. Okay, do you have any question? Okay, so let's look at another example for a super mesh. Okay, obviously this super mesh. Okay, so if you look at here, you have this mesh, and you have this mesh lah. But you notice that this mesh and this mesh are sharing the same current source. So this one's gonna be your super mesh lah. So this one inside here gonna be your super mesh. Okay, so you have three mesh, so that's mean that you need to have three equations, and this three equation is actually coming from this combination of the super mesh lah. Okay, super mesh, let's say this one is I1, I2 and I3, let's say lah. Okay, so this super mesh, one equation is coming from this super mesh, where the combination of mesh I1 and I2 lah. Okay, mesh I1 and I2. The second one coming from this I3, and the third one is the super mesh, the equation coming from this node 0, combination between I1 and I2 lah. Okay, so that's your equations lah for this circuit. Okay, so let's see. Okay, so this is the step lah. Super mesh 1 and 2. Let us see before. Okay, 1 and 2, mesh 3, node 0, and then you can solve the equation lah. Okay. All right, so let's see what it got here. Okay, so So this one is actually your super mesh equation where it's coming from this I1 and I2 lah. Obviously, you can just add this equation like, all right. So 6 plus 1, you will have for mesh 1, you will have 6I1. Okay, this both sharing the same mesh here. Plus with 4I2, plus with 4I2. Plus with 180, and then you need to minus it with 4I3, and then minus it with I3 here lah, 1I3 here, okay, equal to 0. Then you can just simplify your equation here lah, okay. So that's why what you have is 6I1 here, 6I1 plus with 4I2, okay, and you have 5I3 here lah, okay. 4I3, 1I3 here, okay. So that's why you will have negative 5I3 here lah, and then plus with 180 and then equal to 0. Okay, same goes with this mesh lah, okay, where you have 4, 5, 6, 7. You will have 7I3, okay, plus with 90. Minus with I3, minus with 4I2 equal to 0. Okay, so this is you get for your mesh for loop I3 here lah. And also don't forget you have this at node 0. So this one is actually the equation from your node 0. Just look at the, just put a note here. Okay, so this one and this one lah. Okay, what you have is obviously I2 equal to I1 plus with 45. Okay, so that's why you have this equation as your equation 3 lah. And then because you have 3 equation, you can solve your equation using the Cramer rules lah. Okay, you can use this Cramer rule in order to solve your equation, where when you do the solution, you will have I1 is equal to negative 46 ampere. And I3 is equal to negative 20 ampere. And then your I node is obviously, the question asks you about your I node as well, right? So your I node here, okay, let's look, let's just draw this again lah, okay? Okay, let's see the current directions. This one you have obviously, this is I3. Okay, this is your I3. And then you have this as your I node. And then obviously here, using these directions lah, okay? Because your loop is like that, right? So your directions is here lah. So you have this. So means that this one is actually your I1 and this one is your I3 and I node. So if you look at here, your equation is going to be I1 equal to I node plus with I3, so that your I node is actually equal to I1 minus with I3 lah. Okay, so I1 minus with I3, so that you will have this answer lah. Okay, negative 26 lah. I1 minus with I3, where negative 46 minus with minus 20, so you will have negative 26. All right. Okay, guys.
Okay, doctor.
All right. So do you have any question? Am I too quick? Am I too fast? Or you can just follow me? Okay. All right. So let's do this exercise lah. Okay. I think that we still have times to finish this exercise, I guess. All right. Okay, so for this exercise, we have the dependent current source here, right? You have dependent current source here where it was 0.5 I. So you need to find what is your I here, okay? Your I here is actually this one lah. So how many loops did you have for this one? actually you have 3 loops lah. This one we call it as I1, and this mesh we call it as I2, and this mesh we call it as I3. Okay, in this mesh, because this I2 and I3 is sharing the same current source here, so we can have this as a super mesh lah. Okay, super mesh where we have the combination of I2 and I3 lah. Okay, and then we also have this node. Okay, node 0. And then we also have the equation from I1 lah. Okay, so let's see what is your equation for mesh 1 here. Okay, mesh I1 here, the equation is actually just add these two resistor, which is 5k I1. Okay, 5k I1 minus with 3k I2 equal minus with 2. Okay, minus with 2 equal to 0. Okay, so this is your equation 1 lah. Okay, and how about your super mesh? What you have for your super mesh lah? Okay, your super mesh is actually between I2 and I3. Okay, so in this loop for I2, you have this combination of 3 and 2 resistor lah. Okay, so you will have 5k I2, 5k I2 plus with this 4k I3. Okay, 4k I3, and then you need to minus with 3k I1, and then equal to 0. Okay, then you might want to rearrange these equations lah. All right, so where you will have negative 3k I1 plus with 5k I2, and then plus with 4k I3 equal to 0. So this is gonna be your second equation lah. Okay, and then you also have the equation for node 0 here, where this is sharing the same source lah. Okay, so obviously for this node 0, I just write it here lah. For node 0, okay, what you have is just look at the current connections, right? So here the current is 0.5 I, which is entering this node, and then you also have this as your I2, and this one is your I3. Okay, where you have this the equation's gonna be I2 is equal to 0.4 I plus with I3. Okay, you know that your I here is actually equal to here. Your I here is actually, this one is I1 and this one is I2. Obviously, your I here is actually equal to I1 minus with I2. So you can just substitute the value lah. I2 equal to 0.4 times with I1 minus with I2 plus with 3. Okay, this is going to be your third equations lah. So now it seems like you have a complete equation for this one, where you have equation 1, equation 2, and equation 3. So when you solve this equation, you will get your, I just want you to try to solve yourself lah. This equation, I already given to you these 3 equation. So means that you will have I1 is actually equal to 0.5408 milliampere, and you will have I2 is equal to 0.2347 milliampere, and then you will have I3 is equal to 0.1122 milliampere lah. Okay, so now the question asks you to find your V node. Where is your V node here? Okay, so this is your V node, all right? So V naught is actually, obviously, the V naught is actually equal to I3 plus with R5 lah. Okay, I3 mine plus times with R5. Okay, so now you already have your I3, which is 0.1122 milli, and then times with your R5, where you have it as a 3K. And then when you calculate, you can find that your V naught is this answer lah, which is 0.3367 volts. All right. Okay. So between the nodal versus mesh analysis, how to choose your method? Okay, this is when you have a circuit. Then, if the circuit doesn't mention to you what analysis you need to use, okay, whether you need to use the mesh or node analysis. So to select the method that result in the smaller number of equation, of course, if you can have the smaller number of equations, so it's more easier for you to solve for that circuit lah. Okay. So you can choose a nodal analysis for circuit with fewer node than meshes. So if you have fewer node than meshes, you can choose the node analysis lah for your solution in order to solve for the circuit lah. Okay, then you can choose mesh analysis when you have a fewer mesh than nodes lah. Okay, and then just note also the network where it contains many series connected element, voltage source or super mesh. Or super mesh are more suitable for mesh analysis lah. If you look at the series connected element, all right, the series connected element like this lah, the series, right, where you have the voltage source, you have the current source, and in a series. So you might want to opt for mesh analysis lah. But for the parallel connected elements, okay, the parallel connected element like this, where it will create a node. So it's more suitable if you can choose the nodal analysis lah. Okay. If node voltage are required, it may be expedient to apply nodal analysis lah. If you need a branch or mesh current are required, so it's better for you to choose the mesh analysis method lah. Okay.